Welcome to the first video of the first section of the academic chemistry class. The first section is on math for chemistry, and we're going to be dealing with scientific notation for this video and the next video. And in this video, we're going to deal with scientific notation and working with very large and very small numbers. Now, in chemistry, we use lots of numbers. Chemistry is a math-based science. It's called a hard science, not because it's difficult, but because we deal with very concrete numbers. So that means in order to work in chemistry, you have to be comfortable working with numbers. Big problem is we work with very large numbers in chemistry. How large? Well, suppose you go shopping and you buy a bag of sugar. I'm sure like most people, once you get the bag of sugar, you look at it and you go, I wonder how many molecules of sugar are in this bag. Well, it so happens that there are this many molecules, give or take a couple. Later in the year, you will learn how to calculate this number. But this is a huge number. It's 3.95 million billion molecules. That's a big number. Chemistry would write it this way because 3.95 times 10 to the 24th is equal to that gigantic number. We also work with very small numbers. Once again, how small? Well, let's take a single molecule. As a matter of fact, this is a molecule of sucrose, which happens to be the chemical that is sugar, made up of 12 carbons, 22 hydrogens, and 11 oxygens. And you could easily say, well, how much does one sucrose molecule weigh? When you do the calculations, it weighs this many grams, 571 billionth trillionth of a gram, a ridiculously small number. In chemistry, we would write it this way because 5.71 times 10 to the minus 22nd is equal to this ridiculously small number. So we go back to our bag of sugar, and you will note that I have cleverly blocked out the weight. But I could ask you, what's the mass of this bag of sugar? And you can actually figure it out. How, you say? Well, you know the number of molecules. You know the mass of one molecule. So the number of molecules times the mass of one molecule will equal the total mass of the sugar. So you take the total number of molecules, you're going to multiply it by the weight of one molecule, and you can already see that this is going to be a potential mess. And as a matter of fact, there's an easier way to do it, but you're going to have to wait for the next video to find out the answer. This video is set so that you can convert from this number to this number, which are the same numbers, or you can go from this method of expressing the number to this method of expressing the number. Now, for scientific notation, there are three parts to any number in scientific notation. The first is called the coefficient. The coefficient will always be greater than or equal to 1, but always less than 10. There's the base, which in chemistry is always base 10, so that's the times 10. And there is the exponent. That's the power of 10, and it can be either positive or negative. So to go from standard notation to scientific notation, we have steps. You'll find throughout the year that chemistry has lots of steps. I'm going to talk you through the steps, and then I will walk you through the steps. So the first step is you move the decimal point so there is one non-zero digit to the left of the decimal point. Then you write out the base, which in chemistry will always be 10. You count the number of decimal points that you moved, use that as the exponent for the 10, and if your original number was greater than 1, the exponent will stay positive. If the original number was less than 1, then the exponent will be negative. And since I know somebody will ask, if the original number is equal to 1, then your exponent happens to be 0. So for example, suppose you have the number 1234. What is this in scientific notation? Well, the first step is to move the decimal point, so there's only one non-zero digit to the left of the decimal point. So we're going to move the decimal point from here to here, so now it looks like this. Step 2, write out the base. This is the easiest part, times 10, and you must write out the times 10. Step 3, count the number of decimal places moved and use that as the exponent. We started here, we went 1, 2, 3 places over here, so the exponent becomes 3. Now remembering the two little sub-steps, if the original number is greater than 1 and 1234 is definitely greater than 1, then the exponent remains positive, and so we can say 1.234 times 10 to the third equals 1234. Okay, here is one for you to try. Stop the video, come up with your answer, come back and check it, then I'll walk you through it. Go. The correct answer is 5.603000 times 10 to the 6th, though 5.603 times 10 to the 6th would also be correct. We'll follow step 1 and we'll move the decimal point from here to here. So now we have this number. We're going to add the base, so times 10. We're going to count the number of places the decimal point moved. So we started here, we ended here. That is 1, 2, 3, 4, 5, 6 places moved. So we make that 6 the exponent. The original number was greater than 1, so the exponent remains positive. And so 5,603,000 is equal to 5.603000 times 10 to the 6th. Okay, let's try a number smaller than 1. Stop the video, come up with your answer, come back and check it, then we'll walk through it. Go. The correct answer is 3.12 times 10 to the minus 4th. How'd we do that? Well, we started with this number, and just to make it easy to follow the bouncing decimal point, I'll change the color, and we follow the first step, and the decimal point is going to go from here to here. So now we have 3.12 because the leading zeros disappear. We're going to add the base, so we put in the times 10. We're going to count the number of places the decimal point moved. And as a reminder, we went from here to here. So the decimal point moved 4 spaces. So we put the 4 up there. But the original number was less than 1. So the exponent has to be negative. So we change it to 3.12 times 10 to the minus 4th. And then we can say 0.000312 is equal to 3.12 times 10 to the minus 4th. How about going the other way from scientific notation to standard? There are 3 steps here. Step number 1, if the exponent is positive, you're going to move the decimal point to the right, the number of the exponent. If the exponent is negative, you're going to move the decimal point to the left, the number of the exponent. And if you don't have enough numbers, you're going to use zeros to fill in the places. Let's demonstrate this. You want to write 5.093 times 10 to the 8th in standard form. You need to move the decimal point 8 places to the right because this is a positive exponent. So you look at the coefficients and you realize you only have 3 decimal places to move. Add 5 zeros. It doesn't change the value of the number. Now you can move the decimal point 8 places and you get 509,300,000 as the answer. How about a number that is smaller than 1? Here, stop the video, work it out on your own, come back for the answer. And the answer is this number. I'm going to give you the down and dirty way to convert the small numbers. If the exponent is negative, write down the number of zeros in the exponent and put a decimal point between the first and second zero. Works every time. So to review, scientific notation, trust me, is a much easier way to work with very large and very small numbers. And I will show you how to do this in the next video. And in class, I will show you how to use your calculators to do this. There are 3 parts to a number written in scientific notation. There's the coefficient, which will always be between 1 and 10. The base, which in chemistry will always be 10. And the exponent, which is the power of 10 and can be either positive or negative. If the original number is greater than 1, that's when you have a positive exponent. If the original number is less than 1, then you have the negative exponent. There are steps in going from standard to scientific notation. You're going to move the decimal point. So there's 1 non-zero digit to the left of that decimal point. You're going to add the times 10. You're going to count the number of decimal points moved. Put that number as the exponent. And once again, if the original number is greater than 1, then the exponent is positive. If the original number is less than 1, then the exponent is negative. To go from scientific to standard, if the exponent is positive, move the decimal point to the right. If the exponent is negative, move the decimal point to the left. Use zeros to fill in blanks where you need them, and that's it. So that's how you convert from standard to scientific notation to standard. So go do the worksheets, think about all of this, and in the next video, we'll begin to show how you can do math with scientific notation.